We're going to begin this chapter by reviewing the formula for finding a confidence interval. So the first thing that I want to do is go through and write down what all of the symbols in the formula mean. You've seen many of these symbols already. For example, the X with the bar over it, we know that that is the mean. Now, as we move into this chapter, we want to be a little more specific with what that symbol stands for. Very specifically, that is the symbol for the mean of a sample. And we need to make that distinction now because the formula also contains this symbol, which is the mean of the population. All right, this symbol on the top, that's called a sigma, that is the symbol for the standard deviation of the population. Now, in the past, for standard deviation, we have used an S. That S is the standard deviation of a sample. But again, in this particular formula, the formula is asking us to use the standard deviation of the population. And so we have a different symbol. Okay, the N, we've seen that before in formulas. The N is the sample size. And the only other thing that is listed in our formula is probably the part that looks the most intimidating in this formula, and that is this Z alpha over 2. That is actually probably, as we get started, the easiest part of this formula because that is a fixed value, and you can see that down here. It says that Z alpha over 2 is sometimes 1.65, it's sometimes 1.96, and it's sometimes 2.58. And the one that you use will depend on the level of confidence that we're using. And we'll talk more about that when we get to an example. One other thing that I want to remind you of is that the purpose of using a confidence interval is to gather your information from a sample, and then using that information, you want to make a prediction about what's going to happen for the population. Remember that your populations tend to be very large, and so working with a sample is easier. So in all of these problems, you will see the problem telling you that you have gathered a sample and calculated the mean. And then you want to use that to predict the mean for the population. And that is essentially what this formula is going to do for us. So let's go ahead and take a look at our first example. The example says a middle school principal wishes to estimate the average number of hours that 7th grade students study each week. The standard deviation from a previous study is known to be 2.6. So I'm going to go ahead and just jot this down as we read, that the standard deviation is 2.6. The principal randomly surveys 45 7th grade students. So there's our sample. He picks a sample of 45. And he finds from those 45 that the mean study time per week is 8.7. Okay, so be sure that you understand that he picked 45 students. That was a sample. And he calculated the mean to be 8.7. So that 8.7 is the sample mean for this problem. We're going to use that to make a prediction about what the mean for the population is going to be. Let me get that corrected there. 8.7. Okay. The problem asks us to find the 95% confidence interval for the population mean. So I'm going to go back on my other screen and I'm going to look for the z value that goes with 95% confidence. So we can see that that is going to be 1.96. Okay, so we are almost ready to plug our values in. The only thing that I want to call your attention to is I want us to think for just a second about this standard deviation. You need to make a note to yourself whether the standard deviation you are given is the standard deviation of the sample or the standard deviation of the population. Okay, so I'm going to just jot that question down. It's a very important question as we start working these problems. So is this the standard deviation of the population, which is what we need, or is this the standard deviation of the sample? And I'm going to answer that question from going back into my problem and looking when it says the standard deviation from a previous study. So it is not talking about these 45 students that we have right now. So that is going to be the standard deviation of the population. If that standard deviation had been of these 45 students, we would say that was the standard deviation of the sample. Okay, so the 2.6 is the standard deviation of the population. And remember, that's what we have to have, standard deviation of the population, in order to use this formula. All right, so let's go ahead and set it up. Okay, so I'm going to jot my formula down here so we can use that. And then we're going to plug the numbers in. Notice that on your formula, the left-hand side of the formula is exactly the same as the right-hand side of the formula, except the left-hand side has a minus and the right-hand side has a plus. But otherwise, they are identical. Okay, so let's go through and plug our numbers in. So we'll put an 8.7 in for the x bar. The z alpha over 2 we've already said was 1.96. The standard deviation of our population is 2.6. And our sample size is 45. And then we're going to have exactly the same thing on the other side, but with a plus. Alright, so once that's in, then we are ready to go to our calculator with it. We are going to calculate the left side and the right side separately. So the first thing we're going to do is do this part, the 8.7 minus 1.96, and then with that parenthesis beside it. Now, you don't have to do anything special in terms of putting it in your calculator. You can type it in exactly like we have written on the paper or on the screen. All right, we're going to round our final answer to 2 decimal places. So we're going to have, for the left-hand side, 7.94. And for the right-hand side, 9.46. Now, the other thing here is that you want to be sure that you understand what you've found. Remember that our mean of our sample was 8.7, the mean of those 45 students. So we're now saying that the mean of all students is between 7.94 and 9.46. So we're using this 8.7 to make an estimate about what happens with the population.